For this question, they want me to factor the following expression by using grouping. You use grouping when you have 4 terms. In this case, we have 1, 2, 3, 4. We always do. You split it down the middle. You ask yourself, what does the first 2 terms have in common? They both have 1x in common. You bring that x outside, which is a GCF, and do the division process. So you're left with x plus a. Then on the other side, the same. What do those both numbers have in common? In this case, between 6 and 48, you have in common 6 plus 6. Bring that plus sign that you have right here. Open parentheses, x plus 8. Now, when you're doing grouping, you have to make sure that this and this are both the same. If they're not the same, you have to go back and check your work because you must have done something wrong. Then, when you look at all of this, you want to ask yourself, what is in common between this side and this side? And what you have in common is x plus a. Once you take that x plus a, you are left with x plus 6. And that's your answer for this example. In this example, I'm asked to factor the following polynomial. You want to ask yourself, how many terms does this polynomial have? It has only 2 terms. And when it has 2 terms, you want to check to see if there's a difference of squares. You always first check if there's a GCF. In this case, there's no GCF. So then we ask ourselves, 2 terms, the difference of square. Is the first term a perfect square? So if we ask ourselves 25x squared, square root of 25x squared is 5x. Is the second term perfect square? Square root of 9 is 3. And then if it's a difference in the middle, and in this case is yes. So check, check, check. So then you're going to rewrite having 2 set of parentheses, plus or minus. And then you simply just take these things. For the first one is 5x, and then it's 3 and 3. And there you have the difference of 2 squares.